Alright, so in this video we're going to define our own class in Python. And then after we define that class, we'll go in and create or instantiate our own objects from that class. So if you haven't watched the video that I did before on objects and classes, and you need some sort of conceptual background or theoretical background on what we're doing in this particular video, then you may want to hold off on watching this video and watch that one first and then come back and watch this video. So if you remember from that video, if you've watched it, that when we were talking about a class, we're talking about describing something in terms of its data and its operations. And that's exactly what we're going to be doing in this video, is describing something in terms of data and operations. And in this particular video, we're going to be looking at describing a superhero, and that's a particular example we looked at in that video, in terms of its data and its operations. So let's go ahead and get started. Alright, so I'm here in my Python editor. The editor that I'm using, or the integrated development environment that I'm using, is Constructor. You may be using this or you may be using something else. It really shouldn't matter in terms of what editor you're using. So in order to write a class, what we do is just use the keyword class and specify a name of this class. So in this particular case, I want to have a class name superhero. So you can go ahead and type class superhero : and then we need to define that class in terms of its data and its operations. So what we'll end up having is some class variables. So again, these class variables are just things that describe some sort of state, property, data information that will be shared among all instances of this particular class. So we only have one copy of whatever this particular variable is. Each individual object or each instance of this class does not get its own copy of these class variables. And the next thing that we'll have is the constructor. So the constructor is just a special method that allows us to create and initialize a particular instance of this class, or we could say an object of type superhero. So we'll say that we have a constructor. Now it turns out in Python that we can only have one constructor. So if you've programmed in Java or C++, you know that you can have more than one constructor, but that's not the case in Python. And then after the constructor, we'll have what are called static methods. So if you remember from the video, I probably mentioned this idea of class methods. And this is really terminology that you would use for Java and C++ and other languages similar to them. So in Python, you have this idea of both class methods and static methods. And static methods are the closest thing that you really have to class methods in C++ and Java. And we're not going to need in this particular example what the class methods would actually provide for us, so we're going to just make use of static methods in this particular case. Okay, and then after our static methods, we will have our instance methods. So you may have noticed that I haven't specified instance variables just yet. Turns out that we're going to define our instance variables here inside of the constructor. So I'll have another comment here for instance variables. That's basically what we need to have for the structure of our class. Class variables, constructor, instance variables, static methods, and then finally instance methods. And again, we could have both static methods and class methods, and maybe in a later video I will go and discuss the details and differences between class and static methods. But for right now, we really don't need to worry about that in this particular video. Alright, so let's go ahead and start fleshing these areas out. We'll just start here with class variables first. Okay, so for class variables, we're going to only have one class variable in this particular example. So the class variable that we're going to have, this variable that's going to be shared among all the instances, is just our superhero count. So how many superheroes do we actually create or instantiate? So I'll just create a variable called superhero underscore count, and we'll set it to 0. The other thing that I'm going to do is I'm going to make this particular variable private. And the way you go about making a variable private in Python is by using two leading underscores. So what private means is that it's just basically a way to control the accessibility of this variable. And private just simply means that this variable can only be accessed within this particular class. So if we were to import this particular class that we're defining here into another program, then we wouldn't be able to have direct access to superhero. So it turns out that we're going to have to write a method in order to give us the ability to read the value of the superhero count. We don't want to have unconstrained access to this particular variable. We want to only be able to increment the superhero count whenever we construct a new superhero. We don't want to just provide a mechanism where people can go in and change the superhero count to be whatever. Okay, so something I wanted to draw your attention to about class variables before we move on to the constructor is this idea that the class variables are not defined inside of any particular method. So they exist within a class, but not within any particular method. All right, so now on to the constructor. So the way that we go about defining the constructor is using 2 underscores, the word init, and then 2 trailing underscores. And we have to pass in a reference to this particular object that's now being instantiated or created. And the way we do that is by using this word self. And self is just a convention. You could actually use a different word, but it turns out that the very first parameter that's being passed in to a constructor and also to our instance methods should be a reference to the object that we're now instantiating, or in the case of the instance methods, the object that is in fact performing the operation, whatever it may be. So we have self there referring or referencing this particular object that we're now constructing. And then we'll have 3 different parameters in this particular instance. And one of the parameters is just going to be for the name of the superhero. And we'll say that initially, if they don't specify anything for the name, whenever they construct a new superhero object, then we'll just have the empty string assigned there to name. We'll also have another variable called hungry, which specifies whether our superhero is hungry or not. So maybe they've been out fighting crime or doing some other type of mundane activity, and we'll say that initially that they are not hungry if they don't provide us with a particular value. So we can construct a particular superhero that's either hungry or not hungry. If they don't specify a value, then we'll say false that they're not hungry. And then also tired. So tired will also be a Boolean variable, and we'll say that if the person constructing this doesn't specify a value for tired, we'll say that it's false. So that's the header portion for the constructor. And then inside of this, we'll have our instance variables. So for our very first instance variable, we'll just simply have, again, a reference to this particular object, self dot underscore name, or underscore name, assignment statement name. So what we're doing here is making use of this particular variable called name, and then assigning it to an instance variable called name. Now what you'll notice is this particular instance variable has these 2 leading underscores, so we're making this particular instance variable private to this particular class. Users of this class will not be able to manipulate the name in an unconstrained way. The other thing that you should notice is this little dot operator. In a lot of programming languages that support object-oriented programming, you will find this dot operator, and it's designed to basically provide us with access to members of a class. So we're saying that for this particular superhero, we want to be able to access some particular attribute, and in this case, we're accessing the name. So it'd be self dot and then some attribute. So the next things we'll have is self dot underscore hungry, and we'll assign that to whatever they passed into the variable hungry, and then self dot underscore tired, and we'll assign that to whatever they passed in for tired. And the last thing that we need to do here inside the constructor is increment our class variable for superhero count. So whenever we're invoking that constructor, we are now instantiating, creating a new superhero object. So we'll just say superhero, which is the name of our class, and then do dot underscore superhero count, and then we'll just do an increment by 1. And so that's going to be it for our basic constructor there. Okay, so now that we have our constructor, we'll then write our static method. So we're going to have just one static method, and that particular static method is just going to allow us to read the value of the superhero count. So the way we go about writing static methods is we have to use what's called a function decorator. And so we use the @ symbol and then type in static method. And then we'll define our static method. So it's just simply get superhero count, and we don't have any parameters there to pass into that particular method. And all we're going to do is just simply return the value of our superhero count. So superhero dot, and then we'll select superhero count, and that's it. So the reason why we need this particular method is because we declared superhero count as being private. So if we're interested in reading that particular value, then we can do it through this method called get superhero count. And this is typically what you'll see. In most cases, our instance variables will need to be private. Class variables, it really depends, but some of those may be private as well, as we have in this particular case. All right, so on to writing the instance methods. All right, so now we're going to write our instance methods. Our first instance method is going to be a mundane activity. I think I'm going to make a lot of these instance methods fairly mundane. Maybe try to keep away from some violence here. And so we'll have the ability for our superheroes to mow the grass. So we'll say we're going to define a method called mow grass. And we'll pass in self. So it turns out for all of our instance methods that we'll write, then we'll need to at least pass in one parameter, and that parameter being self. So if you've programmed in Java or C++, you're probably familiar with this idea of this, the keyword this, and this simply refers to what? The object that's calling or invoking this particular instance method. So self is the same idea here in Python, except it turns out that we could actually use any word. It's just the first parameter that's passed into instance methods is by default the reference to the object itself. So let's use convention. And so inside of the body of this particular method, we'll just have a print statement, and we'll simply print out self dot, and then we'll select name, so specify which particular superhero is performing this operation, and we'll just say whoever it is mowing the grass. Okay, depends on, I guess, what superhero you're talking about, whether they have to have their grass mowed by themselves or somebody else isn't doing it for them. And then as a result of mowing the grass, maybe this affects whether they're hungry and tired. So we'll say that as a result of mowing the grass, they end up being hungry and they also end up being tired. So we'll say self dot tired is now equal to true, and self dot hungry is also going to be assigned the value of true. Okay, so the next activity or the next method that we'll have is, since they mow the grass and they get tired, maybe we'll allow them to take a nap. So we'll have another method in our instance method definition here for taking a nap. And again, we'll just pass in self, as we should have for our instance methods. And we'll just do another print statement. So we'll just say self dot underscore underscore name. And we can just say whoever it is taking a nap. Okay, so that's fairly simple. So as a result of taking a nap, you can imagine that we're going to be manipulating the tired instance variable in this particular case. So we'll say self dot tired is now going to be assigned the value of false. So this is typically what you'll have in object-oriented programming. You'll perform some particular operation, and as a result of performing that operation, it may manipulate or change our state or our properties. In this case, we're changing the property of being tired or not being tired. All right, so the next instance method that we'll have is another mundane activity, and that is our superheroes can eat. So we'll pass in self, and then we'll also have a second parameter here for the food that they will be eating. So this will be a simple print statement again, in which we do self and specify which particular superhero we're referring to, and we'll say whoever it is eating, well, let me make sure I'm doing a string there, is eating, and then we can specify whatever they're eating. So that's some particular food. And then we'll end this string concatenation with a period. So pretty simple operation there. And so as a result of eating, we can say that they are no longer hungry. So we'll say that they're no longer hungry, so that will be false. We could say that a result of eating, it maybe makes them tired, but I'll leave that up to you if you want to include that. And then the final thing that we're going to do in terms of instance variables is we'll say that our superhero can throw a party. We'll say throw party as the other instance method that we have. And we pass in self, and we'll also pass in the name of the superhero that we're throwing the party for. So we'll just call that particular parameter superhero. And then we'll also specify the food that they're going to have. All right, so in here, we'll just do a couple of print statements. And we'll do print and specify the name of the person or the name of the superhero that's throwing the party. And then we'll have a concatenation operation here. And we'll say that this superhero is throwing the party throwing a party for some other superhero, which we have in our variable called superhero. And we'll say that since that's going to refer to a particular superhero, we can do superhero dot underscore underscore name, and that way we're getting the name attribute for that particular superhero. And then we'll end that with a period. And we can also call other instance methods. So to just give you an example of how we could call other instance methods within instance methods, we could say self.eat. So whichever superhero is throwing the party, then they can eat some particular food. We'll say that they eat whatever the food is. So let me try to type in cake. I guess I'm thinking about cake. But we would need to pass in food. So it may be in the case that they passed in cake to food. So our parameter here called food. And then that value would be passed in here to the eat method. And we could do the same thing for whoever we're throwing the party for. So whichever superhero we're throwing the party for. So that would just be superhero.eat and pass in the value of food. Okay. Maybe we'll do one more. Let's do one more instance method. And you guys are like saying, well, we're dealing with superheroes and they don't do anything that interesting other than mow the grass, well, nap, eat, throw a party. Throw a party, I guess, could be kind of interesting. So we'll say that we will have a fly operation. So we'll just have a simple print statement, print self.name, and whoever it is flying. Okay. Maybe as a result of flying, they end up being tired. So we can say self dot tired is going to be true. All right, so we have our instance methods in place for the most part. Actually, we'll write a couple of more instance methods. These instance methods will basically just be providing us with a string representation, though, of this object. Really, we should write a repr method, which is a representation method, and that provides us with an official string representation of an object that's unambiguous. And then we can also write an str or stir string method that just provides us with an unofficial, informal way to represent this particular object or a particular object as a string. So maybe I'm going to forgo writing the repr method and just write the string method. In reality, you should probably be writing the repr method instead of the string method if you're going to write one of the two. But I'm going to keep things informal here for this particular class definition, but you should be writing a repr method. So let's go ahead and write that particular method. So we'll say str underscore underscore str underscore underscore. So that's just part of the syntax that's needed in order to write this str or stir method. Well, we'll need to pass in the value of self. So that's just a reference to the calling object. And we'll say that if self.tired turns out to be true, so if that's the case, so that's a Boolean value, so we can make that particular statement there. Then we'll say that we have a variable called tired underscore s, and we'll concatenate or assign the value of tired there to that particular variable. So here we're just testing that Boolean variable, and now we're creating a string variable called tired underscore s to represent whether they're tired. If it turns out that they're not tired, so we can have an else operation here, and we can just assign the value of tired underscore s to being not tired. And then we'll have a test to see if they're hungry. So we can do self dot underscore underscore hungry. And if that turns out to be the case, we can assign a string variable here to hungry. Otherwise, else, we'll say that they're not hungry. And then we'll have a return statement here in which we just return some string representation. And so in this return statement, I'm going to be making use of string substitution. So the way that we go about doing that is we can specify a placeholder for our string. So the way that we do that is by just doing a %s. So %s, we can say %s is, so this will be specifying some particular name, is, and then another %s, placeholder for another string, for our string substitution. So this could be, Batman is tired and not hungry. So this, our other %s will basically be representing whether they're hungry or not. So that's the way that we go about representing strings for string substitutions. And then we'll do another %, and then we'll provide the actual variables that contain the information to do the string substitution. So we'll say self dot underscore underscore name, and then we'll do tired underscore s, and then we'll do hungry underscore s. And that's all there is to doing a string substitution. So whatever we have here in name will be substituted in here where we have this first %s. The tired s will be for the second %s, and then hungry underscore s will be for the third %s. So these are just our string specifiers that we have here. Okay, so now that we have our stir method, that will allow us to print out information associated with a particular object in terms of their name, whether they're hungry, whether they're tired. So let's go ahead and go here in main and start creating some superheroes. So the way we go about instantiating or creating new superheroes is just by invoking the constructor. So that was superhero, and then passing in some particular value. So the very first parameter was for name. So we can say maybe the Hulk is the name of this particular superhero. And I think our second parameter there is for whether he was hungry. We can say that the Hulk is hungry and he's not tired, so that's false. And if we want to be able to refer to this particular superhero object, then we can have some variable, and I'm going to just call the variable Hulk. So that is the way we go about instantiating a new superhero, and now we're able to refer to it. And if we wanted to be able to print out the representation of the Hulk, our informal string representation, we could just do print Hulk, and as a result of that, it's going to call our stir method up here, our string method. I'm not sure how people pronounce that. I'm calling it stir. We can have the Hulk do certain operations, so we could say Hulk dot, and the nice thing about PyScripter is it's actually providing us with all the different things that the Hulk could do. So maybe the Hulk goes and mows the grass. So we can have him doing that. We could also have the Hulk maybe taking a nap. So we can say Hulk dot nap. Let me do this. Let's say that after we mow the grass, we'll do a print operation on Hulk. And we'll also do a print operation after we have Hulk take a nap. So let me do print Hulk again. So we can see what sort of attributes or data is actually changing as we perform these operations. So I'm going to go ahead and run this code and see what happens. See if we get any errors. Okay, we didn't get any type of runtime errors there. So initially, whenever we did the print Hulk, we had the Hulk is not tired and is hungry. And after he mowed the grass, so we see the statement there for mowing the grass, and then it says the Hulk is tired now. So he originally was not tired, now he's tired and he's still hungry. And then the Hulk goes and takes a nap, and as a result of taking a nap, he is not tired. So you can see here what's going on in terms of being able to create a particular object and then perform some particular operations. Let's go ahead and create another object. So this is going to be our Spider-Man object. So we're going to invoke the constructor again. And this time we'll say Spider-Man is the name. And we'll say that Spider-Man is also hungry initially, and he is not tired, so the same thing that we had for the Hulk. And maybe the Hulk throws a party for Spider-Man, so who knows, Hulk is very nice. So he's throwing a party for Spider-Man, and then we'll just specify whatever parameters that we need to have. So the parameter that we would have there is, the first one would be the superhero. So Spider-Man is the name of the superhero. And the food that maybe they eat at the party is cake. Let me make sure that that is a string. And then we can see what that looks like. So let's go ahead and run this program again. And so you can see down here we have the Hulk is eating, the Hulk is throwing a party for Spider-Man. The Hulk is eating cake. Spider-Man is eating cake. So if we were to go and print out both Hulk and print out again Spider-Man, or at least print out Spider-Man, we can see what happens. So Hulk is not tired and not hungry, and Spider-Man is not tired and not hungry. So as a result of them throwing a party and eating some cake, they're no longer hungry. And we'll do one more superhero. We'll do Rogue. So here we go for Rogue. Again, we got to invoke the constructor and pass in the name. So the name here is going to be Rogue. And we'll say that Rogue is not hungry, but she is tired. And maybe we'll have Rogue do some flying. Say Rogue.fly. And see what happens. So let's go ahead and run this again. And so you can see here that we have Rogue is flying. And if you wanted to make, Spider-Man or the Hulk fly, we could do that, right? So you could say Hulk.fly. You're probably saying, well, Hulk and Spider-Man don't fly. Well, maybe they're on a jet or something. Who knows? So they could fly, I guess, in certain situations. So we can have Hulk is flying. So hopefully this has provided you with a basic introduction to objects and classes in Python. Certainly there's a lot more that we could talk about in terms of objects and classes. So we've just sort of skimmed the surface, but maybe it gives you an idea in terms of what's going on. Whenever we define a class, we're defining something in terms of data and operations, and then we can go and instantiate or create objects from that class and have them perform certain operations. Those operations may result in changing their state or their properties. All right, so that's it for this video.